Thank you all for availing your time and joining us in the SAEON seminar. This seminar will be recorded and it will be added to the SAEON YouTube page for later viewing. Welcome and thank you. Today we have Dr. Shirley Parker-Nance. She's based at SAEON. So Shirley is a Turkish graduate that moved to PE, Gqeberha now as we know it, to do her honors at the University of Port Elizabeth, Zoology Department. This was followed by Fisheries Focus, Masters of Science on the Pilchard Sardinops, and a PhD in Taxonomy on Ascidians of Algoa Bay. After several postdocs, contract posts, a marriage, 2 daughters, and some new species later, she took on a second PhD in reef ecology. This was complete during COVID season, and she received her degree in 2021 from the Department of Ichthyofauna at Rhodes University in absentia. 3 months ago, Shirley joined the SAEON family as the Shalom Marine and Coastal Research Infrastructure, SMCRI, Benthic Ecosystem Long-Term Ecological Research Coordinator. She's with us today to tell us a bit more about this new platform at the Elwandle node. Shirley, thank you for making time, and we're looking forward to hear you and the work that you do. Thank you very much. Over to you.
Thank you, Pumulile. It was very nice. Welcome to everybody. Good morning. Yes, this is a hopefully not too long a talk, although, well, we can only hope, on a small introduction on what we plan to do with the Benthic Ecosystem Long-Term Ecological Research platform that's being established at Elwandle node here in the Eastern Cape. I'm going to run through some slides with you, and then if you have any questions, please feel free to ask them at the end. Okay, let's see. Right, we are all acutely aware of South Africa's terrestrial biodiversity. For most, however, the organisms that live in the ocean is largely hidden from our view. And even if we are unable to see below the water surface, signs are clear that the environment around us is changing. This is evident by the increasing extreme ocean events such as storm, flooding, algal blooms, of which many are harmful to other biota, mass mortality, stranding, and pollution. Increased innovation and technological advances have, however, allowed increased access to the ecosystems previously largely hidden and difficult to access and assess. So just as an introduction, just a couple of definitions that might be pertinent in this talk for those that are not so much involved in the marine system. For those that are, just bear with us, please. As an introduction, I would like to say the Benthic refers to the bottom substrate of a sea, in this case, or lakes or rivers. Benthos refers to the organisms that live on or in the sea bottom, or in the case of some fish, in the bottom water layer. An ecosystem, and here I provide the definition as given by Henderson, our faithful guide, is a distinguishable community of different species interdependent on each other with their non-living environment, which is relatively self-contained in terms of energy flow from their neighboring communities. Also, some terms that might come up is habitat and biotopes, which are subunits of an ecosystem and are used interchangeably in many cases, although the biotic subject of a habitat is a population or species, and the biotic subject of a biotope is a community consisting of assemblage of species. Ecology, on the other hand, refers to the interrelationship between organisms and their environment and each other, as well as the study of these. So now that you have been reminded that biodiversity is not a terrestrial phenomenon, but also marine, I bring us back and focus on what we do at SAEON. For this, I borrow a couple of sentences from the document that would describe the framework of South Africa's core science plan compiled by O'Connor in 2010. Society's response to environmental change requires sound information and understanding of long-term patterns of change. The mandate of SAEON is to develop a sustained and dynamic South African observation and research network that provides understanding based on long-term information. SAEON's responsibility rests on three mandates: observation, information, and education. Most of us, or you, are also very familiar with this map. South Africa's climate, its biodiversity, and fundamentally its natural resources, distribution and abundance are largely governed by two major ocean currents and the wind. Warm tropical water of the Agulhas Current, the strongest western boundary current in the world, flows southwards along the east coast of southern Africa. It is pushed increasingly offshore to an ever-widening continental shelf, lending to a transition from a warm tropical climate of the Algoa and Natal ecoregions to the warm temperate Agulhas ecoregion. The Agulhas Current contributes warm water over the continental shelf in the form of Natal pulse, while wind-driven upwelling events drive productivity as cool, nutrient-rich water is pushed to the surface. The Agulhas Current, governed by the strength and the position of the wind fields over the Indian Ocean, split with the bulk of the water retroflecting eastward as the Agulhas return current. The complement, in the form of eddies, or better known as the Agulhas rings, are transported around the tip of the Agulhas bank and enters the Atlantic Ocean and supplies warm saline Indian Ocean water into the Atlantic Ocean. On the west coast, the cool temperate waters of the Benguela Current, which are fed by the South Atlantic Current, flows northwards along the west coast of the South Africa, driving productivity. Now, if we do a little whiteboard exercise with this, and we look and try and summarize some points that drive South Africa's unique marine climate and bring it into context with SAEON Elwandle Coastal Nodes plans shallow marine and coastal research infrastructure rollout along the South African coast, we can see that our current Sentinel site here in Algoa Bay, which stretches from Taspent in the west to Port Alfred in the east, and includes two of the large embayments, St. Francis Bay and Algoa Bay. This Sentinel site has been operational for about a decade now, and plans for future expansion of the observation network includes the establishment of a Sentinel site in Cape Town, the Two Ocean Sentinel site, and that north of Natal, the Natal Bight Sentinel site. In between, along the South African coast, and as well as our island, the Prince Edward Island island group, there are a number of satellite Sentinel sites that will be included in not only the BELTER platform, but also the other observation platforms, including pelagic and temperature data collections. So how does BELTER actually fit into what is currently established for Elwandle Research Network? And we can see that the Benthic ecosystem long-term ecological research platform, or BELTER, and from now on I will say just BELTER, is one of several research networks which facilitates long-term research. This can be, the long-term research at SAEON can be divided into three major data sets: the Sentinel and Satellite Long-Term Research Network. The current includes BELTER, or the Pelagic Ecosystem Long-Term Ecological Research Platform, the long-term monitoring of rocky shores, sandy beaches, and extensive suite of CMPs, or continuous monitoring in situ observations. A second is the National Estuary Network, which informs on physical, biochemical, and biological variables associated with estuaries. And lastly is the extensive South African National Coastal Temperature long-term research network, which multiple parties contribute to. And you can see this is a little map I actually borrowed from one of Tommy's talks. And that is the current distribution of the temperature loggers in shallow water along the South African coast. So it's quite extensive. Now, just to get back to what our focus is with BELTER, BELTER will focus on the collection of data from the inshore ecosystem and more specifically the inner shelf. Now, the inshore, as it is given by the National Biodiversity Assessment, and I will quote, are those marine ecosystem systems influenced more by wave energy and light than deeper offshore ecosystems. It includes the environment from the shallow marine shore to the fair weather wave base. The fair weather wave base is the depth at which waves influence or agitate the seabed under normal conditions. And this ranges from a depth from 30 to 50 meters, depending where you are offshore, off the coast of South Africa. Now, the inner shelf is the specific focus point here, which stretches basically from the back of the surf zone to the fair weather wave base. So that gives you a sort of idea what the depth is where we will be deploying our instruments. But let's start small, the fundamentals. The knowledge and data infrastructure BELTER is built on. And if you look at this slide, it is sort of an idea, a flow chart of what we do. Included and have been doing for the last 20 years, I've been compiling and collecting species from the reefs, South African reefs. And what we do is we would collect a specimen here. The specimen, selected specimen, we take underwater photographs of that. When we have collected it, we also take freshly collected photographs and sometimes even of the preserved specimen. These are all entered into a database, and the database obviously gives all the metadata for every single specific specimen and also includes data that was generated while identifying or describing these species. So this is sort of a shoebox on steroids. And then from this side, we then take this species after we have looked at it and identified it, and we actually include the classification. We use, with building this system over the years, we have been able to compile a large reference database within this database. And for instance, here you can see that we have selected the genus Pseudostoma, and it will come up with all the Pseudostoma species currently known for the South African coast, also with images of these, so that if for instance, a person that is not necessarily a taxonomist or are familiar with these species, they can actually just click on this and it will auto-populate the identification. So I know, for instance, we have collected this specimen. As a ecologist, I know that is in my picture. I will use this database. I could click on it and I would be able to obtain the identity. Then from where we collected the specimens, we would, all our morphological specimens are curated in the collection at SAEON, the South African Institute for Aquatic Biodiversity in Makanda. And with this, we transfer all the metadata to their cataloging system, which is run by Specify. And this includes, again, all the imagery and metadata for these species. And then the specimens are then available for study by any other person or entity. But this database is also used in the top database to generate a traits labeled database, which we use and incorporate in our analytic tools for the data we collect by BELTER. So, for instance, when we use the software we use is Transect Measure, and in that you populate a library, and by searching the library for instance, a group, a sponge, a SAEON, it would come up with a collection of images you can use to identify a species, or you can use any sort of trait. The shape, the morphology, it's round, it's ball-shaped, it's a mushroom. So you would see that there's actually some writing at the bottom. These are codings for the trait which that software uses to retrieve the images. Now we actually only get, once we have the collections and the libraries in place, now we can actually look at how BELTER has been able to be established, because we have all the fundamental data that we can actually identify species in place. So for the collection of the benthic substrate or biota images, we use a jump camera system. You can see here, here's Melissa. Hi, Melissa. I know you're in the audience. Here's Melissa. And me working on, I think that was Quabalana still. And we have this huge jump camera that can basically take an image of about 0.4 meters square of the bottom of the ocean. It has camera housings there inside. We lower this onto this bottom, and we then collect these wherever we lower it at a specific reference sample location within a station in a site, a Sentinel site, which is selected. The image you see here is one that we've been working on for the last 5 years. It is White Sands Reef, just off Port Elizabeth, or off the golf course. There you can see there's the actual golf course, Flat Rocks Reef here. And we have been sampling some of these are the new sampling locations for the BELTER, but a subset of these were sampled for the pilot study to check that everything works and test out the methods of collecting the data and analyzing the data. So this is basically what we do. We have a reference location, and we try and collect samples at this reference collection. You can see here's the actual position of each sample in correspondence to that collection. This is a 50-meter diameter, so we're pretty spot on to collect data from a specific point in our grid. Then the next step for us would be basically to take the image. We superimposed a grid of points over it, and then we basically do image identification by looking at what we have on that point, and we look for the species, and then we click. This is actually based on a code system. So each one of these species, you can see at the end of the trait name, there's also a number. This is a number that never changes, because we are actually working in a field where many of the species are still yet unknown to science. And you will see some here on your list here, SPMKB. This was identified by Michelle Kelly-Borges at the stage where the Elwandle Research Foundation found this black liver sponge. It's not been described, but we know it's P0011. If it ever gets described or gets the name or even the genus changes, because we haven't described it, we can always refer back to the code and repopulate the species list with an updated species list. So this is a code that never changes. It is actually sort of grounds and connects all the other work, the taxonomic work that is done on these organisms. So basically, at the end of the day, we have a species list that we can generate for each of these quadrants that we collect. Now, once the collected images also then allow for the construction of substrate and biotope subunit libraries. This allows for image-based identification of the substrate and a robust visual comparison and identification of characteristic communities. So identifying species at this level is very time consuming, and you can think there's 216 points here, I think, if memory serves me right. And this would take you, a person that's been doing it for a while, at least an hour to an hour and a half to complete the species list. But if you are not familiar with species and haven't been spending a lot of time in the environment or looking at the species, it takes a while to get used to what is what or what looks like. And sometimes it's just easier if you have an image that you collected to say, oh, but this image looks like a very sandy sort of substrate with some red and green algae on it. So we use these substrate libraries to add metadata to our image libraries or to our stored images so that it's easily retrievable. Anybody that look for unconsolidated sediment samples will then just be able to extract those that include sand. The same works for the biotopes. Now, biotope is a unit that's defined on the species composition and the substrate, so the biotic and the abiotic. And if we look at the biotopes, for instance, here I have 2 biotope subunit O that was defined. We do know that it has coralline, articulated coralline algae here, a mix of soft microalgae, and it's a bin because it's very small and cannot specifically be identified, and an encrusted coralline algae. And that makes up, if we look at the contribution or the average abundance of each of those components within the habitat, that would actually tell you what is in there and would actually define the biotope subunit. So we have a whole library of this. Any student or somebody can reference this library and look at this image and say, oh, what I just collected looks similar like this. So we can expect to find these species there. This again, with this biotope subunit, it differs, it looks different, it's visually different. And so we can add some of this data to our image that are stored to help with the processing or training, or actually just making the images more retrievable, so that anybody doesn't have to get all the images at once and just can select what they need. So this is a quick reference system that helps us to access the data and bring out quick assessment of the collected species. So from this, from our previous study, and this is a pilot study was done on all the data collected for 2 of stations in the Algoa by Sentinel site, just to check if BELTER was a feasible platform to roll out, if the data was able to observe changes in the environment, and what we would get out of the data. So in the pilot study, and the pilot study included Benthic, 32,000 Benthic data points. For this site, there were 2 sites, so it's about 77,000 data points on species for the study, and we were able to assess how, if it's a feasible initiative. So as you can see from here, we have, and this is very robust in a way, because we do not at the moment have multi-beam data for bathymetry. We have the technology within SAEON and SAEA, but we do not have the access to it in Algoa Bay at the moment, but it will hopefully come. This is done purely on known bathymetry, and we use the biotopes identified in that study, which includes the abiotic and abiotic component of the biotope, to actually describe each of the biotopes. This is biotope 1, was a larger biotope study. We can see what species were found in it, and we know that it occurs at a depth between 4.6 and 7.6 meters. If we look at the second one that we found here for all these, this one is found, all the samples were found from a depth of 12 to 17 meters. It was more rocky reef gravel, abiotic substrate with these biotic organisms found to grow on it. So we get a really fair, robust idea of what is in our habitat, how's the species distributed, and so on. Now, mostly and have collected data on the benthic invertebrates and algae found in a region. We can also incorporate some information on the fish. Now, why fish? Because we know that nearshore fish species are heavily impacted by increasing fishing pressure and habitat transformation and loss. The use, and there's not the us, the use of different environments or biotopes within the seascape by ichthyofauna has important management implications. We do acknowledge that. Another point of interest is that reef-associated fish develop a wide variety of benthic reef, or depend on a wide variety of benthic reef invertebrates for their food, refuge, place of safety, and in many cases, which we have now been able to establish with other work done in shallow systems, also for nursery areas. And then also changes in the associated reef fish populations due to fishing pressures has been shown to drive changes in benthic community composition. And from this statement, we can actually say that changes associated with the reef fish populations due to other pressures, even such as climate change, will then also drive changes in the benthic community, and vice versa, where the benthic community composition and changes due to stress factors, both anthropogenic and natural, will drive changes in the fish population. So to actually assess the benthic ecosystems, we need to include both the benthic sessile invertebrates, or sedentary and sessile invertebrates, as well as the fish. Why is the benthic sessile and sedentary fauna actually of importance here? It's notable that these animals can, of course, not run away from adverse conditions, so they make excellent subjects for study. Whereas for fish, they do rely on a certain community or biotope structure within to live, but they can largely also move. So a good study, which I always remind me of and sort of brought clarity to me many years ago when I wanted to wrap my head around ecology away from taxonomy, I found that the study by Ali Gotts and his team in the Gokama Marine Protected Area, where they investigated the effect of fishing on benthic reef communities, showed this very clearly. And this indicated that the fishing pressure on the reef population associated with the invertebrate communities drive the change of the community. So if a decrease in, for instance, of the red Roman would see different feedbacks for where other fish, not only benthic species, but also other fish populations are influenced by the either increase or decrease of a certain species. Very interesting paper to always read. So it is thus essential for us to understand and observe the change in the benthic algal and environmental communities, and to do so, we also need to measure the physical and biochemical essential ocean variables. That is understandable, and that is provided by a network of in situ observation stations already managed by SAEON, as well as the biological variables associated with the fish or the ichthyofauna that makes use of this benthic environment. So we need to look at both the abiotic, the physical, the biochemical variables, and take into account the biological variables, in this case, those animals that live on the bottom of the ocean that cannot move, but also those animals, the fish, that are associated with those environments. And here I just give a short little video to show you how the data collection for the fish is done. We use baited stereo-baited remote underwater video systems, which allow for not only counting the fish, but also measuring the size of the fish that is present at the time of the image collection. Again, back to our map. And now that we have looked at the fish and sampled the fish, we can relate the community or the complement of fish species that use a specific biotope. And here I have again biotope 1, which was our shallow system here. All these fish were recorded for there, and you can see here I've included the average abundance. This is untransformed, so this is real abundance of these different species that was found there. Franz Madame and strippies, stinkies, and blacktails were the main component here, where on the deeper side, you can distinctly see, although there were fewer different species, also the number of species that contributed and the abundance was different. So this is valuable parameters to know when we sample this year after year or in different seasons, that we can compare these abundances found and the distribution of certain species. In the preliminary pilot study, it was shown that, for instance, fish community or populations found, communities found at different biotopes were different for even for different seasons. Not all seasons, but definitely differ between some of the seasons. So interesting fact. So in summary, BELTER aims to enlarge the report on biological essential ocean variables, and these include invertebrate abundance and distribution, fish abundance and distribution. This will complement the essential ocean variables already measured by SAEON Elwandle Coastal Node, where they collect biological EOVs, phytoplankton biomass and zooplankton biomass and diversity, physical EOVs, temperature, salinity, and current, and biochemical EOVs, nutrients and carbon. I think we can now, I'm not sure, under correction here. BELTER also aims and adhere to and promote to the FAIR principles, which is principles to ensure that data collection and curated data are findable, accessible, interoperable, and reusable. And elaborating on the interoperable side of things, interoperable means that we could use data collected from different areas in the world or by different people, and to facilitate this, we use ocean best practices that adopt best practice methodologies which have been adopted and employed by multiple organizations and allows reproducible results and ensure that the data is interoperable. Okay, then we at BELTER also believes and would support emerging research. So it's not a research in stasis. We could continue to contribute to ocean-based practice. We hope to contribute positively to the Ocean-Based Practice Task Team 2022-01, where coastal observations in under-resourced countries are assessed. This addresses the need to identify common and acceptable best practices used for observation of physical, chemical, and biological parameters of the ocean, with a focus on the African continent or countries that are under-resourced specifically. And in this, I hope to assist in adapting existing and developing coastal observation infrastructure and methodologies for the African continent and its needs specifically. So looking at what we have now, where certain infrastructure, certain equipment is used, but it costs a lot, or you have to have a lot of financial support and backing, and how we can make it useful and applicable to even countries which do not have the resources we currently have here. Okay, I think that wraps it up for me currently. And so if there are any questions, I will be happy to answer. I can ask you. Thank you. Phumelele?
Thank you very much, Shirls. That was a nice presentation. Full of
I
data.
thought you fell asleep. I thought it wasn't
No.
diapers. Oh, okay.
No, I'm wide awake. Sorry. All right, thank you very much for your presentation. Are there any questions directed at Dr. Parker-Nance?
I don't see anything in the chat.
I think you were spot on. Everything was straightforward. Okay, we've got Cloverly.
Hi, Cloverly.
Yeah,
Over
hi
to you.
there, Shirley.
How are you?
I'm good, thank you. How are you?
Very well, very well. Waiting for summer. Had enough winter.
Oh, you and me both. Shirley, this is so exciting work. Thanks so much for sharing this. And yeah, I just had a couple of questions around the visibility. You know, if you are using the jump or the cameras, how do you cope if there's a limited or low visibility or light penetrating, you know, and how do you sort of adjust for that? Or do you just try to pick days when it's clearer? And then I wanted to know how if you're able to pick up things like mollusks, particularly abalone, or, you know, things that are more cryptic, are those showing up in your images? Thanks.
Cloverly, on your first question, this is definitely good sea day, good weather, good visibility research. There's a bias that we know of because we're using images. If you go deeper and it's darker, there's a difference between darkness and bad visibility in a way that even if it's darker, we can attach lights to the systems, both the jump camera and the BRUFs, and can still record the images. But if it's soup, like we many times get in Algoa Bay, and it's just green, there's very little you can do except pack up and come out again when the visibility has improved. So definitely fair weather sampling. It is a limitation, but there's very little we can do on it. The pros of it, of course, is that this way of sampling it definitely beats going down there, even if you can't sample, and scraping the biota off the substrate and coming back to the lab to identify them. First of all, currently we do no harm to the reef, and we are able to actually observe the same areas so there is no destructive sampling. So definitely there's pros and cons to both, but definitely we are all up for sunny, clear water days. Then on your second part for seeing mollusks, frequently we can see nudibranchs. A lot of them, even if they're small, that is very easy. I think it's because nudibranchs, they're just, they don't mind being exposed or being on the outer, not hiding away. In a way, they are on the top of sponges or ascidians and are not really, I think they don't fear really being eaten by predators because of the chemistry and things they repel. Then abalone or Haliotis medae or Spediciae for that matter, I have not seen any in gem camera work. I know from personally diving on and measuring abalone, you do get an eye for it, and but they do tend to hide underneath algae, especially moving algae in the water column. So and they tuck themselves in. Also, their skins are prone to a little bit of fouling at times. So, and the ridges and the color is a very good camouflage. So it is very difficult to pick those up. And I have not that I specifically collected samples yet from areas where a lot of abalone use it, like off Cape Recife or Bird Island. And it is something we can investigate to see how useful it is. For the big ones, I really don't see a problem. You should be able to pick them up if they're really large. But for the little spat, I don't think there's a way you're going to see them. Okay, does that answer your question, Cloverly?
It does. Thanks very much.
Anybody else? Okay, thank you, Shirley. This is GS. I see Dr.
Yes,
Gavin Snow. Hi, Gavin. Thank you, Shirley. The talk provided a good description of the overall structure of the monitoring structure. This is a very practical design. Looking at some of the images, this would take me days, weeks to identify the species composition in each sample. Thank you, Gavin. No, that is good. Yeah, it is a lot of work, but very rewarding. At the end of the day, to have a nice species list, but like I said, you need the fundamentals of actually also the taxonomy behind it, the good wet morphological collection, and the whole, and it's a living science, because yeah, I would say, at least for the South African, and Tufik can correct me here if he hear me at the moment. I think only, and this is being very conservative, maybe 60% of South Africa's sponges, robust big sponges, have been described. It might be much lower than that. So we're working with a lot of species that we just don't have names for yet. So we need more taxonomists. Anybody else?
Okay. Seems we've run out of questions. All right, Shells, given that then we have the government looking into economy opportunities in the marine environment, how effective would this data and images be in trying to eliminate habitat transformation that would wipe up some of this biodiversity?
Well, I think one of the main aims here is to do just that, to highlight if something changes. For instance, if for instance, and this is sometimes on a short-term basis, there was somebody was really bad and trawled over the shallow reefs somewhere and ripped it all apart. You would immediately see things like that, mechanical damage. But you will also see the effects maybe, and we hope to see, like pollution in the water column, that it might affect certain species. I know from visual observations, and this is before we actually took photos, that over the last decade, during the summer seasons now, it is very prevalent that filamentous algae covers the bryozoan outcrops at Balboy in the shallows, where the water gets really hot during the summer months, December, January, where was not apparent many years ago. It seems to be indicative. Now, if this happens, it has a knock-on effect in that the algae actually smothers the bryozoans, the big bryozoans' heads falls off, and it clears space on the reef. So those things you would be able to see when things like that changes after a fouling event or something. So I think this is a very good way to monitor any change or changes in the species composition at a certain area. We also have to remember, and I didn't note this in this talk, that we're not only looking at what species are present and absent, but these images can also pick up certain species traits or growth, like growth form. We know that some species, you might find the same community, but in some areas they grow lower, or they're not so high in the water column due to certain more current or less current or anything like that. And those might be very good parameters to note as well. I had another, over time, there was another aspect of your actual question, which gone out and I don't know what that was. But anyway, yes, I think this is a very good way of, and of course you can keep these images and years of the year you can compare them and see, okay, now we've lost these species or the species composition has changed. Yes. So yes, and of course now we sit with the problem that in many areas there is no baseline currently for this. So all the work we will start rolling out now will actually form the baseline for this. So we know this is what it looked like in 2022, you know, when it looked like in 2023, because of it's just not available at the moment. So yeah.
Thank you very much. Cloverly has her hand up again. Over to you.
Thank you. Hi, Shirley. I mean, I just absolutely wanted to follow up with what you were saying about, you know, looking at impacts over time. And I mean, I'm thinking specifically around the increase in ship traffic, increase in, you know, the frequency of oiling in the bay. And I'm wondering whether, you know, I'm sure you have that in mind already. And, you know, where you're planning to expand, you know, your monitoring is it going to look at places like high impact areas versus lower? And are there indicators of, I don't know, you know, impacts of this excess carbon in the water that indicate a species that can be identified with that type of impact? Thanks.
Yeah. Yes, Cloverly. I think it's a very important tool, especially here in Algoa Bay, and I get where you're coming from. Firstly, areas that would be included in the observations as stations, as research stations. This one was part of the PhD, and we're continuing with it. The rollout of other research stations of similar extent will be in direct communication with the stakeholders, of which, of course, you are one very important one. So don't forget that. So we will get, the idea is to do similar work for Bird Island, as well as there was the area around the SMCRI Islands, which is very close to the anchorage and the port, which is also very one would think affected by things like the oil spills and oil sinkage to the bottom and things like that was included in the initial study, and the baseline for that does exist at the moment and was pre the Greater Addo Marine Park, the first lot of samples taken. But we need to really sit down and actually look at, I don't think things like that has been assessed. I know that carbon input into sediment has been, the sinkage of carbon and in areas like that, but how it could be visually seen on benthos, except that the growth might be affected. It will take more investigation and see, I think with routine sampling and taking those events in consideration, like using when these events occur and sampling before and after, you would get some information on that and some evidence of these effects. But yeah, it's a completely new science. So yeah, very good.
Thanks.
To use it.
Thanks very much, Lily.
Yeah,
right.
And I mean,
Thanks.
The nice thing is with the park, it's not a nice thing that it's so close to it, but being able to monitor into the park these sort of things, you could see how it affects from the border to in the park, and relate that to currents, movement of the water masses, and distribution of these pollutants. So yeah, it is something we will have to address in Algoa Bay, where the two is so closely aligned.
All right,
Okay.
thanks, Shirley. Julia commends you on the work that you've done, and it makes her think of similar work in the terrestrial environment. And then Erica Brown is asking if this information is available online. Do you have any access issues? And I think a more important question goes on to say, do you see a place for this work in oceans accounts and natural capital accounting to inform accounting processes underway in South Africa?
I do see a place for this sort of work. I think it's fundamental to put that in ocean accounting, because it's to know what is down there is essential in knowing how to use and how your value of your resource. So yes, definitely for that. I do see it. We would have to open some more communication lines to determine exactly what is needed from that, from ocean accounting, exactly what is the data products that is needed to contribute to those sort of projects. Yeah, but I do think this has a place there. And then, Eric, huh?
Accessibility.
Accessibility. Yes, the Erica, I have been employed for exactly 3 months and 3 days. Yes, it will be made accessible, I promise. The idea is to get it out as soon as possible. In this, of course, getting data products out takes longer, but our aim would be to get the collected data product, so the actual images that we collect for anybody else to use out very fast. As soon as they cleaned up a name, they go up and anybody could request them to do their research on them as well. So there's a multi-layer product here. It is the raw data or the image itself. And then, of course, our scientists at SAEON and our students and whoever works with us, that the product from that research will also be made available. So yes, definitely. The only point in collecting this data would be to make it available to be used.
Thanks for that.
And accessible. So to get, but that we have a whole data team for to help with, as you know. And so
All right,
Great.
thank you very much, Shirley. Any other questions from the audience?
5 more minutes.
My internet is starting to be unstable, so I might.
That's okay. It's your coffee is cold, your internet unstable. I'm freezing actually. I'm sitting here going like this. I want my jersey on, but it wasn't very
Okay.
nice looking jersey.
Shirley, we don't see any other questions. Just one more for future Benthic ecologists. If one were to want to go on into this career, what would you basically encourage them to do from the onset of the biology degree and then going up into postgrad? What qualities do you think one would need?
Relentless tenacity to not give up. It's hard work. I had a mentor, or he's still around, a friend and mentor that used to say, you are better. Colleges can actually only understand its environment it works in if it spends the time in it. Now I've tried that many times. I lie on my stomach on the ocean floor, looking at these little quitters running around, and the whole other team is floating around and chasing sharks. And I'm looking at these little, just looking and seeing, so like sitting in a valley. And I believe that to know your subject, have passion for it, and never give up. It is basically, you can do any aspect of it. There's so many interesting and exciting avenues in Benthic research and mapping and modeling, and especially for all the computer junkies that want to include AI and ML. It is very exciting. And I can see in the next 10 years that old school people like me that sit and and identify by hand will largely fall away because of these extra technologies and expertise that younger generation can bring to the fold. So I think if you can stand with one leg in the natural environment, dive a lot, learn your environment, experience your environment, and on the other hand, your technology and embrace technology, nothing can stop you. And
Thank you very
will
much.
contribute a lot to our knowledge, faster and better.
Thank you, Shirley. Thank you for your time and thank you for the presentation. If there are no other questions from the audience, let's join another SAEON seminar on the 1st of July. Faith Jumbi from the Faimbos node will be telling us about understanding the impacts of land cover change on landscape flow pathways in critical water source areas for improved modeling and resource management. Thank you everyone for availing yourselves, and we shall see you again on the 1st of July.
Thank you everybody for listening.
Thanks, Shirley. Thanks, Boom. Bye-bye.
Bye.
Bye.